Video we're going to look how to solve equations involving difference of squares. A basketball player's hang time is the length of time he is in the air after jumping. Given the maximum height h a player can jump, you can determine his hang time t in seconds by solving for t squared minus h if h equals 0. If h is a perfect square, this equation can be solved by factoring using a pattern for difference of squares. I had no idea what a good vertical jump should be, so I did what you would do and I Googled maximum vertical jump, and this is what I found. So looking for a number that'd be nice, perfect square. It looks like we could use 36 inches could be a vertical jump height. And that's going to make a nice problem, actually. If we do 4t squared minus 36 equals 0, I could divide both sides by 4, and then I'd get t squared minus 9 equals 0. Using the difference of two squares factoring technique, I'd have t plus 3, t minus 3 equals 0. And then using the zero product property, I have 0, t plus 3 equals 0, so t equals negative 3. Someone's traveling in time. T minus 3 equals 0. So t would equal 3. So that's the only real solution I get out of that. This could also be solved using a little bit of simple algebra. If we just move the 36 to the other side with addition, divide by 4, and then take the square root of both sides, we get t equals plus or minus 3, because negative 3 times negative 3 is 9, positive 3 times positive 3 is 9. And of course, once again, we cannot have negative time, and so we get t equals 3, and this was in seconds. Seems long to me, but I don't know. I'm not a vertical jumper. Okay, it says solve by factoring, so we're going to get everything on one side of the equation, subtract 3y from both sides. And then my greatest common factor is 3y, so I'm going to factor that out. 48 divided by 3 is 16. Y cubed divided by y is y squared. 3y divided by 3y is 1. And then I have difference of two squares inside the parentheses, so 4y plus 1, 4y minus 1. Oh, I'm going to have three answers. My equations will be 3y could equal 0, 4y plus 1 could equal 0, 4y minus 1 could equal 0. Divide by 3, and we have y equals 0, subtract 1, divide by 4, y equals negative 1/4, add 1, divide by 4, and we have our three solutions. So y could equal 0, negative 1/4, positive 1/4. The braces mean order does not matter. You could write them in any order you want, or I'm okay with this too. Just circle your answers. A square with side length x is cut from a right triangle shown. Write an equation in terms of x that represents the area A of the figure after the corner is removed. So we know area of a triangle is 1/2 base times height. Our base this time is 8, and our height is 16. So half of 16 is 8. 8 times 8 is 64 was the original area. So our area after the corner is cut out is going to be 64 minus area of a square is x times x, so x squared. What value of x will result in a figure that is 3/4 the area of the original triangle? Show how you arrived at your answer. Really, thanks. Didn't know we needed to show our work. Okay, so I went 3/4 of 64, so 64 and the 4 will cancel. 16 times 3 is 48. So I want my new area to equal 48. So I could subtract 48 from both sides. And I get 16 minus x squared equals 0. Conveniently, we can factor this with difference of two squares. It's odd having the number first, but it's the same pattern. Something squared minus something squared, we factor it into something, the square root of that something plus the square root of the other something. Yep. So this time my two little equations, I have 4 plus x equals 0 and 4 minus x equals 0. So x equals -4 or x equals +4. We're talking about a length of a side. It cannot be negative. So the only answer that makes sense is 4. I'm making up fake units. I'm calling them centimeters because we should have a unit. It would be nice. You can apply the zero product property to an equation that is written as the product of any number of factors set equal to 0. Using any factoring technique that we have.